let's look at another example again. Write the ordinary differential equation y power 6 plus tan of t y prime prime plus y is equal to k squared plus 1 as an autonomous system in the matrix 4. Now let's look at the solution. Now the original equation is y power 6, that is it, plus tan of t y prime prime plus y is equal to k squared plus 1. Now we let x1 equal to y. We differentiate these two, you have x1 prime that is equal to y prime. And our x2 is equal to y prime. We differentiate this, you have x2 prime that is equal to y prime prime. We have our x3 that is equal to y prime prime. You differentiate these two, you have x3 prime that is equal to y prime prime prime. Now x4 prime is equal to y prime prime prime. You differentiate the two, you have x4 prime that is equal to y even. Our x5 is equal to y even. You differentiate this, you have x5 prime that is equal to y v. Now our x6 is equal to y v. You differentiate the two, you have x6 prime that is equal to y power 6. Now since the order of the equation is 6, you end here and then you now write your original equation, that is y power 6 plus tan of t y prime prime plus y is equal to k squared plus 1. Now we are saying that our y power 6 is also equal to x6 prime. So you have our x6 prime plus tan of t, and our y prime prime is equal to x3. So we have x3 here plus our y is also x1. So we have x1 here, that is equal to k squared plus 1. Now making x6 prime the subject, we have x6 prime is equal to minus x1 minus tan of t x3 plus k squared plus 1. Now our x5 prime is equal to x6. Then our x4 prime is equal to x5. Our x3 prime is equal to x4. Our x2 prime is equal to x3. Our x1 prime is equal to x2. Now we will now write this equation in our autonomous system. So we have x1 prime that is equal to 0x1 plus x2 plus 0x3 plus 0x4 plus 0x5 plus 0x6. Now our x2 prime is equal to 0x1 plus 0x2 plus x3 plus 0x4 plus 0x5 plus 0x6. Now our x3 prime is equal to 0x1 plus 0x2 plus 0x3 plus 0x4 This is x4 plus 0x5 plus 0x6. Now our x4 prime is equal to 0x1 plus 0x2 plus 0x3 plus 0x4 plus x5 plus 0x6. Now our x5 prime is equal to 0x1 plus 0x2 plus 0x3 plus 0x4 plus 0x5 plus x6. Now our x6 prime is equal to what you see here, which is minus x1. Then because we don't have x2 in it, means here will be 0x2. Then we have minus tan of t x3. Then we don't have x4, so we have minus 0x4. Then we don't have x5, so that would be also 0x5 minus, we don't have x6, so we have here to be 0x6 plus our k squared plus 1. Now, if we are to write this, it in an autonomous system, we will have our x prime, x1 prime, x2 prime, x3 prime, x4 prime, x5 prime, x6 prime. This is equal to, now our first x1 prime equation, this one, is giving us 0, 1, 0, 0, 0, 0. This should be 1, 2, 3, 4, 5, 6. Then the next one is giving us 0, 0, 1, 0, 0, 0. Then the x3 prime, x3 prime, our x3 prime is giving us 0, 0, 0, 1, 0, 0. Then the x4 prime is what you see here. It's also giving us 0, 0, 0, 0, 1, 0. Then our x5 prime, this is x5. Our x5 prime is giving us 0, 0, 0, 0, 0, 1. Then the last one, our x6 prime, is what you see down there, this one. That is giving us minus 1, 0, minus tan of t, 0 here, 0 here, 0 there. Then you have here to be x1, x2, x3, x4, x5, x6, plus, now don't forget that we have our k squared plus 1 here, which means that here will be x plus what? Plus, this will be plus 0, plus 0, plus 0, plus 0, plus 0. We are bringing plus 0 because of k squared plus 1. So we have here to be 0, 0, 0, 0, 0, 0, k squared plus 1. Now, this is the solution of the problem.